Hello, hello, hello.
Yes, sir. You may audible, sir.
Yeah, everyone is there, or we have to wait for more 5 minutes?
Actually, total 13 members, sir. Will we add more? Another 6 members want to wait, I think.
Okay, then we will wait for 5 to 10 minutes and then we'll start.
Okay, sir.
Good evening, sir.
Hello, good evening, sir.
Yeah, good evening, sir. You may proceed, please. Hello.
Hello.
Ah, yes, sir.
Yeah, we can start at,
Yeah, please, sir.
yeah.
Okay.
Hello, everyone. Good evening.
Yeah,
Hello.
good evening. Good evening, sir.
Good evening.
Good.
Uh, am I audible to all of you?
Yeah, yeah, perfectly.
Yeah. Okay. So my slides are visible to all of you.
Yes, sir.
Okay. Great. So here we today learn about the polymerization and polymer. What is the polymer technology exactly? Okay. So till now, I think the introduction to polymer technology or introduction to polymer. Then again, in between that, also the types of polymer or what is polymer. Then polymeric molecular weight, crystalline or amorphous nature of polymer, and many of the things I think you have learned in recent lectures. Okay, so can you means hello? Yeah, so can you tell me like what all things you have gone through it? Hello.
Yeah, that
I will just revise all the things in 5 to 10 minutes and then we will start. So, what all things you have learned in last 4 to 5 lectures? 4 lectures, I think.
We have learned on monomers, different types of monomers, organic, organic, and this thing bio polymers. Then copolymers we have learned. Then
Yes.
two types of this thing bonding that we have learned.
Okay.
One
Like
is
that glass transition temperature, crystallization temperature, and
yes,
that heat deflection and crystallization temperature.
my screen is visible to all of you.
Yeah, yeah.
yes.
Slides are there. Okay. So till now, whatever you have learned, like we will start it from like revision of yours. Like what is first of all, what is polymer? Okay. So what do you know by polymer? Means to which thing you can call it as a polymer?
It's a chain of monomers. We call it as polymers.
Yeah, the polymers are a structure, or we can say a molecule, or we can say it as a macromolecule, not a molecule, but we can say as a macromolecule or a giant molecule formed by the addition of your repeating units, which we called as a monomer. Okay, so that linking of many of the monomers will form your polymeric structure. Okay, and the method or the process of the formation of polymer, it is called as a polymerization. Correct.
Ah,
So yes, so today we are will look at the methods, or we can say it as a approaches to polymer synthesis. Okay, so till now you have learned about the polymer related things, uh, like affect which all things will affect the polymer in general, not in details, but the polymer which we call as a means polymer. So how that polymer will get synthesized, or how will that polymer get prepared. So polymer means, as you know, in last slide we have talked about like the process is called as a polymerization. Okay, so there are some general approaches to synthesis the polymer. Okay, so out of that we have divided uh, we have divided the polymerization process in three main steps. Okay, so first of all is like we can say not steps but three different methods. First is like addition polymerization. Okay, then ring opening polymerization, and third is your condensation polymerization. Okay, so what do you mean by addition polymerization here? So here, if you consider by adding same repeating unit, or we can say monomers in a chain continuously. Okay, so in that way we can call it as a addition polymerization, or we can say it as a chain growth polymerization, as we are saying like your chain growth is done by addition of continuous addition of your monomers. Okay, so here the difference in that three of these types we can see in our next slide, but for now at least definition we will go through. So second is like ring opening polymerization. So in this, we are having monomers in the form of ring structure. Do you know about ring structure?
Yeah, yes, sir. Last time it was shown.
Okay, yeah, that's great. So ring opening polymerization, and third is like condensation polymerization, or we can call it as a step growth polymerization. In that, two or more monomers will get react to form, or will react in stepwise manner to get the polymeric substances by eliminating some molecules like water. Okay, so here we can see the major differences between addition and condensation polymerization. Have you learned about this addition and condensation polymerization before in recent four lectures? Hello.
Yeah, last classes it was taught.
Okay, so you all are knowing about the differences between addition polymerization and condensation polymerization.
Yeah,
Okay.
yes.
Okay, so have you observed anything on the screen that you can explain it through? Like what do you mean by addition and what do you mean by condensation polymerization?
Last class it was told that wherever there is a covalent bond, additional polymerization will happen. And
Okay,
here, here it is not necessary. It should be, and if it the covalent bond, if it is not in main chain, then in some cases there will be covalent bond, but it will not be on the main chain. Then also it is additional polymerization.
okay,
Condensation polymerization, most of the time water will be released. So
yeah.
that will be the
So it will release in the form of condensate, or whatever condensate we will get as a water or any of the byproduct. Okay,
uh,
so the major differences are like addition polymerization involves the linking of your monomers, which are already present in the form of double bond. So one of the weak bond we can call it as a pi bond. It gets break and the monomer addition will take place. Okay. So again the double bond of one monomer breaks, as I said, and link it onto the neighboring monomer. Okay. This process continues as shown in below picture, as you are seeing here. One by one monomer is getting added in your chain. Can you observe that? Hello.
Yes, sir.
Yeah. Again, in condensation polymerization, we can see like condensation polymerization occurs between two or more than two functional monomers having two functional groups. Okay. Here, what do you mean by functional group? Hello.
OH are functional groups.
Yes.
And then ON something will be there. NO.
Okay. So, functional group is nothing but like if you are having some, for example, some hydroxyl, acidic, or amine, or in that way, the we called it as a functionality of your molecule. So in this case, for condensation polymerization, your monomer should have at least two functionality on your monomer. Correct?
Which case?
So
Functional polymer.
condensation polymerization I'm talking about.
Okay.
Okay. Here you can see in your very first point, like condensation polymerization occurs between monomers with two functional groups. Correct? So
Uh,
if you are considering like functional groups of hydroxyl. So your monomer should have two hydroxyls on it. Correct?
Yes.
Yeah, in that way. So during the reaction, a small molecule is given off as the monomer bond covalently to produce a polymer. Suppose if two monomers are getting together or reacting together, so it will form a covalent bond, and one of the molecule here we can consider it as a water molecule will get released. So you can observe here in a picture. Okay, here in condensation in second picture is there. So two of the monomers are getting reacted, and whatever the water molecule is releasing over it. Correct?
Okay.
Have you understand?
Understood. Understood.
Okay, great. So these are the basic difference between your addition and condensation polymerizations. Okay. So here are some of the addition polymers are there, which are formed using addition polymerization. All of these you can see like vinyl monomers are there. Okay. What all examples are there like polyethylene, polypropylene, or PVC? We can say it as a polyvinyl chloride, polytetrafluoroethylene. These are the some examples of polymers which can be formed or which can be synthesized using your addition polymerization. Okay, out of which their examples or you can say their applications are given here in next column. Like if polyethylene is there, all of you are knowing about the uses or applications of polyethylene. Correct? At where you have observed that polyethylene examples of polyethylene. Hello.
Sir,
Poly,
SDP, LLDP.
Yeah, that all are grades of your polyethylene. Then I am asking about the applications.
Plastic bags.
Like plastic bags are there, bottles are there, toys. Then if
And
suppose some
human bags.
package, yeah, in some packaging applications. Okay. Similarly, you can observe your applications for polypropylene, PVC, and PTFE, which we called it as a Teflon. Correct. So all of these polymers are formed using your addition polymerization. Okay. These are the some of the examples for condensation polymerization. Here you can see like polyester, or we can call it as a mylar or Dacron, or polycarbonate. Then again polyamide, we called it as a nylon. Okay. So these all are the polymers which can be formed using condensation polymerization. Okay. Here in you can say third column, raw materials for their polymerization are given here. Okay. Suppose polyester is there. So what are the requirement of polyester? It is like some diacid or we can say polyacid should be there. Okay. So the acid or the molecule which have two acid groups on it, like two functionality. Which two functionalities are there?
C3H2 and H2O.
Which one?
HOOH are functional groups, sir.
Yes, COH. That is a acid functionality. Here on first monomer, two acid functionalities are there, and on second monomer, two hydroxyl functionalities are there. Correct?
Oh,
Yeah. So these two monomers are getting reacted with each other to form your polyester. This is by the condensation polymerization. Okay. So we'll
what is
look.
one doubt? What is the pros or cons of that additive polymers and condensation polymers kind of
It is
advantage?
not like a pros and cons. It is having its types depending on your type of monomers or type of polymer. Okay. So if you are having unsaturation in your monomers, it will react or it will form polymer with the help of addition polymerization techniques only. Correct?
Okay.
And if you are having means if you are not having like unsaturation, or you are having some like two or more functionality on your monomers, we will react that monomers, and out of it will form the polymer, means that polymerization we can call it as a condensation polymerization. Means no pros and cons, as you asked, nothing is there in that sense. Okay.
Okay.
Yeah.
There it is only one particular thing, and here it is two different
Yeah,
polymers.
in this case, in this condensation polymerization case, two different monomers with bifunctional, or we can say two functionality we are using to synthesize a polymer.
Okay.
Okay.
Within polymer, there can be different monomers also.
Yeah, we can say like different monomers are there with different functionalities which can be react together.
Okay.
Okay. And here we can see the main reaction. Uh, the main reaction site is your unsaturation in this case, in addition polymerization. Here also we can use a single type of monomer or a multi-type of monomer together to form a polymer. Correct? As
Okay.
here, two or more type of monomers are required in condensation polymerization.
Mm-hmm.
Correct?
Yes, sir. Yes, sir.
Yeah. So moving forward, we'll go through some short terms which generally we use for polymer or polymer related fields. Okay. So first is like monomer. Okay. So as of now, you all about like monomer. What is the requirement of monomer is nothing but it should have minimum two functionality over it. Then only we can call it as a monomer. Okay. So out of it, if we continuously react the monomers with each other, we will get polymer. So polymer is a second term. Okay. We can call it as a macro.
In monomer, you told two functionality, that one single line is one monomer. Huh? In the previous chart you have shown.
Yeah.
So one
That is
line is
that.
one.
Yeah. 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 Here,
In the,
here only you are asking. No?
no, in the second one.
Yeah.
Here there are two rows for each and every polyester, means two rows are there, components.
Yes.
Components meaning is one set of monomer, and second is the second set of monomers.
Yes. Correct.
And both will have two row
Yeah, both
functional.
you can see here both are having two functionalities over here. If you see like in case of polyester, here two monomers are there. First is having two functionalities of acid. Second is having two functionalities of your hydroxyl. Can you observe here
Mm-hmm.
near to my
One is,
near the cursor?
uh-huh.
This is your hydroxyl containing compound. Here at the
Yes.
end of this molecule, two hydroxyl groups are there. Correct? And above
Yes.
that, if you see the molecule over here, two acid groups are present there. Correct?
Okay. So one side it should be a acid, and another should be a
Yeah, it is
hydroxide.
it is it is for polyester only.
Uh, but both can be acid also.
Yeah, but no. In that case, if you are having both acids, then how you are going to react this?
Okay. So
In case of polyester, you require one at least acidic, and one is having hydroxyl groups.
but second case second is also the same
Yeah,
hydroxyl.
second is also the same. But if you are seeing here, their commercial names are mentioned over there. Okay.
Oh,
So in that case, your whatever the number of carbons
mhm.
are present that are different on your uh, monomer containing acid. Have you
Oh,
observed that?
yeah, yes, carbon
Yes. Yeah. Depending on that molecule, your polyester grade will get changed.
oh,
Okay. Yes. So next to that, uh, we are having only three to four terms like monomer, polymer, then oligomer. Okay. What is the oligomer now in this case? As we know, monomer is a single unit or single molecule. Again, if you are going to react this till some molecular weight compound, okay. So if suppose 10 number of or 10 or 20 number of monomers will get react together, it will form some molecular chain. Okay, so that shortest molecular chain or polymer, we can call it as a oligomer. Okay, so if we again going to react it with many numbers of your monomers, then it will form bigger chain, which we can call it as a polymer. Okay, so some of the definition, one of the definition is like degree of polymerization. I think you have already learned about it in previous lectures. Degree of polymerization. Okay, the total number of repeating units contain terminal groups. Correct. Degree of polymerization, have you learned about? Hello.
No, we don't remember, sir.
Yeah. I think the lecture of like
Last class it was told repeating numbers and weight also.
yeah. In
Weight
that
and
in that as well, your degree of polymerization is there. Okay. Degree of polymerization is nothing but the number of your repeating units. Okay, which contain your terminal groups. Okay, that is nothing but your degree of polymerization. Again, polymers can be divided in your three types, which we can call it as a homopolymer, copolymer, and terpolymer. Okay. So what do you mean by homopolymer? So in this case, if you consider the examples from our previous pages, if we have only single monomer as a repeating unit in your polymer, suppose if we reacting only ethylene monomer to get polyethylene, so we can call it as a homopolymer, as it is having only one kind of repeating unit. Okay, have you understand?
yes, sir.
Okay, so in second, it is like copolymer. Okay, what is copolymer? It is nothing but if you are reacting two types of monomers with each other to form a polymer. Okay, here we can consider it as a copolymer in this slide. Okay, all of these polymers we can consider it as a copolymers. Okay,
Sir, in previous slide, last one, previous slide. No, no, not this one. Before this one.
yeah,
CF2 is also monomer. Sorry.
this
That
third example,
last one, last one.
last one, yeah, this is your nothing but your fluoroethylene. Okay,
Polytetrafluoroethylene.
yeah, out of which you will get the polymer which we called it as a polytetrafluoroethylene, which is nothing but your PTFE, or we called it as a Teflon.
Okay. And
Okay,
this one, first one is same one.
yeah, but here the major difference is your functionality. Here we are having fluorine as a functional groups.
Fluorine.
Okay,
Okay.
yeah. So third is like terpolymer. Okay, which we can consider it as a three kind of monomers if we get reacted with each other. So we will get a polymer. We can call it as a terpolymer. Okay. So again,
Sir,
copolymer have.
any example of terpolymer, please?
Okay. So in case of suppose if we can consider here again polyester. Okay. Suppose if half of these acid monomers, if we take second acid monomers which is present here in second example. Okay. If we use these two type of acid monomers and one type of this hydroxyl monomer, and these three types of monomers, if we react, we will get some polyester. Okay, correct.
Yeah, yes.
Yes, sir. Yes, sir. Understood.
To that we can consider as our terpolymer.
So in terpolymer, there will be always two acid and one hydroxyl
Yeah,
or
no. It is not the case. We can.
no?
I am just telling this the example only. You can consider it as if we are using these diols. Okay, this is nothing but your diol, which is
Oh,
containing two hydroxyl groups. You can use two types of diols and one kind of this acidic or diacid. In that case, so you can call it as a
terpolymer.
yes, correct. Okay. So next is like the types of copolymers. Okay. As of you know the what is copolymers are. If there are like number of monomers like two monomers if you are going to react with each other, so it will give you a copolymer. Okay, so first is like homopolymer, which is having only one monomer with it. If we are having like monomers arrangements in your polymeric chain is in random fashion, so we can call it as a random copolymer. Okay, if your monomers having like alternatively bonded with each other or alternatively reacted with each other, so we can call it as a alternative copolymer. Okay, third is like nothing but block copolymer. What do you mean by block? If your monomers are getting react in the form of a block, like if you are having a number of or a type of monomers are present in 3 to 4 monomeric group, and B is having other group, so that groups will get react, so we will get the block copolymer out of it. Okay.
Sir, one doubt.
Yes.
PP, it was told that naphtha will be in the gas form, it will become continuously sir, compressed or something. It is getting bonded and monomer from the monomer, we are getting the polymer. Chain of homopolymer is getting.
Yes.
Yes. Understand. But
Yes.
if you want to have some AB means somewhat the gas of naphtha and some other
No,
material.
no, no. It is having like from that naphtha you are getting your monomers only, okay,
Hmm.
out of it. Again, then monomer, if you react in this fashion, you will get the polymer.
That is continuously homopolymer, it will get generated.
Yeah, if you are having a means kind of monomer is like same, then you will get homopolymer.
For random and copolymer, or in these cases,
In this
that
case, you want to take different types of monomers.
then what happens? We have to inject in that fashion. You have to
Yeah.
open the wall, close the wall, open the wall. Like that, we have to open or how?
No, 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 not in that way. It is having some different polymerization technique. Okay, and it should like it it will require some specific type of polymerization technique with specific type of initiator, okay, which allows your first and second monomer to react alternately. Okay,
So,
we can call it as a controlled polymerization actually. Okay.
but for practical understanding, is it like injecting of one
No, it is not like that.
injection?
If you want it like practically, you can say like it will follow the sequence, like if you are adding your monomers, okay, your monomer first monomer will get react to second and then again first in that way.
Okay, okay. The chemical reaction will be like that.
Yes, yes, yes.
It's not the item which we place. The
No,
reaction
no, no,
is in
no.
that way.
It is not depending on your physical addition.
Mm-hmm.
Yes.
So because of
So
the elements in the chemistry, it has to be like A then 2B.
yes,
So that's how we are giving an input with the
yes,
covalent, single valent.
yes. It is nothing but your control polymerization system.
Okay, okay, okay.
Okay. Okay. So third is like block, and the last one is like graft copolymer. Okay. In that case, your polymeric backbone, or we can say whatever polymeric chain, is made up of your single or you can say same monomer, and the branching to that polymer will be of your second monomer. Okay. That branching we call it as nothing but your grafting, or you can say it as a graft copolymer. Okay. So there are again, if, we already seen like polymerization processes are there like step growth, chain growth, and ring opening. Okay, so first of all, we will start it with like step growth reaction polymerization, or we can call it as a condensation polymerization. Okay, so condensation polymerization majorly requires, as we already mentioned, two functionalities on a single monomer. Okay, where we can call it as a monomer to have difunctional group present in it. Okay, one having both reactive functional groups in one molecule. Like suppose if we have like recently an example, like one molecule is having 2 hydroxyl on its functionality, correct? Have you observed here? There are two different functionalities are there on this monomer.
One one hydroxyl and
Yes,
one acid.
yes. So, but the requirement is like two functionalities are there. Okay.
What is R, sir?
It is nothing but you can consider it as a polymeric chain, or you can say it as a carbon backbone, or you can consider it as a 2 or 3 number of carbon like CH2, CH2 in that way. Okay. It is
Okay.
nothing but a short representation of your monomer.
Okay.
Okay. Similarly, here you can observe in
The main
second
chain,
exam.
monomer.
Yes.
R is the actual main chain monomer. Whatever we continuously have to.
Yeah, but we can consider it as a backbone of your monomer.
Okay.
Okay. It is just a general representation, whatever in between we are having. Suppose in this example, like very first example, if you consider here C, then CH2 4 times, and then COH, correct? So whatever inside this the chain is there of 5 number of carbons, that we can represent as a single, as a R, correct? Okay.
Okay.
Again, you can observe your second kind of monomer, which is having two functionalities again, which are having two different functionalities here. One is like your acid, and one is amine, correct?
Okay. H2N is amine.
NH2, NH2, yeah. Okay. Here only one kind of monomer is getting reacted with itself. How? So here you can see here your hydroxyl. If suppose you can consider two monomers of similar kind, like which contain these two functionalities. Okay. So hydroxyl functionality of this one will get reacted with carboxylic, or we can say acid functionality of second monomer, which is present there. Okay. Hello.
Okay.
Okay. So similarly, your monomers will getting added continuously stepwise, and after addition of each monomer, one water molecule will get released as a byproduct. Okay. So
Okay.
in this case, we can call it as a condensation polymerization. Okay. Similar way, if you are seeing the second example, which is having these two functionalities over here. Okay. If you consider similar kind of monomer again for addition to it, so to this acid group, whatever present here, your amine of second monomer will get react here, and you will get this linkage, whatever present here, like NHR, then C double bond O in that way. So this will, if you continuously add the monomers on these sides, you will get the polymer from this condensation polymerization. Are you getting?
Yeah, yes, sir.
So again, one of the example we can see here for condensation polymerization, whatever the PET, okay, PET means polyethylene terephthalate we are using as a drinking water bottle, okay, so that we called it as a polyethylene terephthalate, okay. So how that PET gets synthesized? So PET, or we can say it as a polyethylene terephthalate, will get synthesized using your condensation polymerization reaction. Okay. So what all raw materials, or we can say monomers, are required for this type of polymerization? So in that, which one is the first? Hello.
Which one is the?
These two type of monomers are required for polymerizing your polyethylene terephthalate. So first monomer is your,
Ethylene glycol.
yeah, we can call it as a ethylene glycol, which is having two hydroxyl groups at the end. Okay, with
Ah,
two number of carbon chain. Okay, so this is your nothing but ethylene glycol, and the second one is terephthalic acid. Okay, terephthalic acid is nothing but it is having a ring structure with two carboxylic or two acid groups. Okay, as you can see here. Okay, so what will happen in this case? Hello.
Copolymer would be formed.
Yes.
A copolymer of ethylene and terephthalate.
Yes. Copolymer will get formed again. Okay. Suppose if you consider these two functionalities. Okay. So to form a polyester is nothing but a means we already seen the polyester in the form of polyethylene terephthalate. We are taking example here. So ester linkage you know about, which is having structure like here. You can see here. Can you observe here?
okay.
Okay, this is nothing but your ester linkage. We will get it by reacting your hydroxyl functionality with your acid functionality. Okay.
Okay.
So similar way, if you can consider here, if we are going to react this acid group, okay, this acid group with your hydroxyl, you will get here one ester linkage over here, correct? So if you are continuously adding to each acid one hydroxyl over here, so you will get a polymeric chain, okay, which will consist your this repeating unit. Which repeating unit is here? Like this is nothing but the
Voice is feeble, sir.
yes.
Your voice is feeble. Not able to hear.
Hello.
Now, okay.
Okay. So which kind of repeating unit is here? Which consists of your part of your terephthalic acid, okay, and one part of your ethylene glycol. Okay, this kind of repeating unit is present here in your polyethylene terephthalate, and the byproduct which we get from it is nothing but water. Okay, so this is nothing but the example of your condensation reaction.
So you call that COS? The
It,
before there is a CO.
this,
What is that you called as?
yeah, if you can draw the structure continuously, okay, you will get this kind of thing over there, which is present at other side. Have you observed here?
Yeah, it is
Yeah.
CS,
If
CS.
you if you if you attach this CO on this side,
Okay.
okay, you will get the similar type of structure. Okay. This is nothing but the repeating unit of your polymeric chain. Okay.
Oh,
Repeating units means what? This same unit, if you attach here
okay.
again and again, you will get your polymer. Okay. So same thing is there.
Okay. So
Okay.
in this one H is missing. Okay, that is coming out as H2O. Okay.
Yeah. That is coming out as a H2O.
Okay. So for the first CO, we call it as what is the name of that one? You second one you told from
That is
ethylene.
ester linkage only. See, this is
CH2 CH2O
this is
is
nothing but your ester linkage. Okay. Again, if you consider, as I have told you now, if you if you connect this repeating unit on this side, okay.
okay.
So what it will be here, CO already present out of your this or can be link over this bond, okay. So it
Okay.
will be like CO OCH2, whatever it is. On this side also CO OCH2, correct? So it
Okay.
will form your ester. If you connect this at this side, so it will also form your ester. So in
Okay.
your whole polymeric chain, only ester linkages are there.
Okay.
Okay.
Mhm.
Yes. So that's why it is called as a polyester. Your polyethylene terephthalate is nothing but the class of polyester only. Okay.
Poly- Okay.
Yeah. So the second example of condensation polymerization here we can consider it as a synthesis of your nylon 6,6. Do you know about nylon?
Left side six chain and right side six chains of
Yeah,
carbon.
correct. So what all raw materials can we use for nylon 6,6 are presented here. Okay. One is like your adipic acid and second is like hexamethylene diamine. Okay. What are the structures basically? These two are nothing but the monomers required for synthesizing your nylon 6,6. Correct. So what basically adipic acid consists of? Which functionalities are there?
Hydroxyl and
Yeah, it is not a hydroxyl. It is again acidic.
but
It is carboxylic acid here. Correct.
carboxylic
Or we
acid.
can say carboxylic structure is here. Correct.
Okay.
This side as well as this. So adipic acid consists of your two acidic functionalities at the end with 6 number of carbon chain. Correct.
Carbon chain. Okay.
Again, if you consider our second monomer, okay, which is like hexamethylene diamine, it is also having two functionalities at the end and having 6 carbon number chain, and the functionalities are
First
nothing but,
functionality we call it as amine. Last one is also amine. Huh?
yeah, both in this case both are your amines.
Okay, we
Okay.
can H2N or NH2. Both are same. Huh?
Yeah.
Okay.
Okay. So in this case also, if you are going to react these functionalities to each other, okay, you will get amide linkage. This is nothing but your amide. Okay. In previous, what we get here, ester linkage. Correct. That's why we called it as a polyester.
Okay.
Okay. Here we get amide linkage. Okay. What is the structure like? C double bond NH. Correct. This is nothing but your amide linkage. How you get this amide linkage? By reacting your amine functionality to your acid functionality. Okay.
Okay.
Yes. Here also we will get H2O as a byproduct. Correct. Like NH, you are out of this NH2, NH is here. Correct. So one hydrogen, and from this this OH, okay, this
Uh-huh.
OH, one O and one H is there. So we'll get H2O out of it. Okay, as a byproduct
Uh-huh.
in the form of your condensate. Correct. So that's why it is called as a condensation polymerization. Okay, this is nothing but the second example of your condensation polymerization. Which one can you repeat that? Hello.
Acid, adipic acid, one set of acid getting synthesized with H2 and amine to
Yeah.
form this, what we
Yes.
call
We can call it as a
Amide.
polyamide. If you are having amide linkages or repeating unit with amide linkage, this repeating unit you will consider as many times as we reacting it. Okay. It will form a longer chain with this repeating unit. So we can call it as a polyamide. Okay. We can
polyamide.
call it as a polyamide 6,6 or nylon 6,6.
So
Why we
amine
are calling
to amide.
what?
Amine is changing to amide by
Yes. Amine will get changed into amide by reacting with your acid group. Correct?
what is that acid you told?
This is nothing but adipic acid.
The individually the two end function group.
You can call it as a carboxylic functionality or
Carboxylic.
carboxyl functionality.
Okay.
Okay.
Why
So it will
amide
give,
we are telling you that hygroscopic in nature?
yeah, it depends again on its structural properties. Okay. What kind of structure we are forming here. Okay.
With it, water is extra there. That's what we are telling
No,
hygroscopic.
not because of that. Because of this amide functionality, you can consider it as a hygroscopic.
Okay.
Okay. It is having some structural characteristics over each polymer. Due to that, your polymer will get behave. Okay. That is
Okay.
again we are going to learn it in our structure property relationship. One lecture is there. Okay. In that lecture, we are going to learn that thing.
Okay.
Okay. So for now, how your polymer will get synthesized using your condensation polymerization. Here, after these two examples, is it clear to all of you?
Yeah, yes, yes.
Okay, why it is called as a nylon 66 here? Do you think that?
Both sides six carbon chains are there.
Yeah, both sides six carbon chains are there. That's why it is called as a polyamide 66 or nylon 66. Okay.
Okay.
Okay. Now we will move forward for ring opening polymerization.
In same case, nylon 6. Okay, now you are okay. Okay,
Yeah,
nylon.
yeah. Yes,
Okay.
correct. So we seen here addition polymerization. Okay. Then after that here condensation polymerization. And third, what we are looking for it lies it's a ring opening polymerization. So basically for ring opening polymerization, this kind of monomer you are required of, which is called is a here we can take example of like caprolactam. Okay, caprolactam is nothing but the monomer required to polymerize your polyamide 6, or we can call it as a nylon 6. Okay, what will happen in this case? So you already have six membered or six carbon membered chain here. You can count it like first, second, third, fourth, fifth, and sixth. Okay, six carbon chain is there. Not chain, six carbon ring is there. Correct?
Okay.
Okay, so that six carbon ring will get react using ring opening polymerization in presence of your catalyst, or we can say it as an initiator. Okay, in presence of high temperature and vacuum. So in the rightmost side you can see the step by step synthesis of it. Your this ring will get open in presence of your initiator. Okay, so you will get a uh, means you will get a starting of your polymerization in form of chain. Correct? Here you will get amide linkage over here. Can you
Oh,
observe this?
yeah, yes, sir.
Yeah. So it again get if you are getting added again and again some caprolactam monomer, so your chain will get open, and again that continuously, or sorry, your mm, ring will get open and chain will get formed. Correct? So at the last here you can see polymeric chain with six carbon repeating unit with amide linkage you will get here. Okay.
Okay.
So this is nothing but your ring opening polymerization. Okay. So as of now, as we seen here, one more example have been given here for your condensation polymerization. It is nothing but your nothing for your polyurethane. Okay. So all of you know about the polyurethane.
Okay. Yes.
Yes. Can you tell where we can use this?
Seats, cushion,
Yes. Again.
and
Many of the applications are there for polyurethane. Foams. Foams can be made out of polyurethane.
that's a seat cushion form. That's what.
Yeah, yeah, yeah. Again, coatings.
Coating for
Polyurethane
what?
coat, polyurethane coatings or paints, we can say.
Okay.
Okay. So how that polyurethane will
Can you
get
use PU as a dampening BIW?
Yes, 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 yes. We can use. Okay. So here, what all raw materials or what all monomers can be used for synthesizing of your polyurethane. Okay. So the basic, as per the basic requirement of your condensation polymerization, monomer should have two functionality. This polyol is having two functionality with two hydroxyl group on it. Okay. And again here one new monomer is there which we use for polyurethane, which is called as a diisocyanate. Okay. Isocyanate is nothing but it's having two NCO groups, or we can say functionalities to it. Here you can observe at the end of this, you will see the NCO functionality over it, correct? Again, if you can see this NCO functionality of this diisocyanate will get react with your hydroxyl here, correct? So it will form your urethane linkage. Can you see here? Okay. This we can call it as a, hello.
Yeah, sir.
Yeah, this we can call it as a urethane linkage. Okay. As we have seen already, in polyesters, we have ester linkage, then polyamide, amide linkages are there. Then again polyurethane. So here urethane linkages are there, correct? So urethane linkage, how you will get the urethane? By reacting your isocyanate, or you can say it as a NCO group or NCO functionality with your hydroxyl functionality. Okay. So that repeating unit, you can call it as a urethane. Okay. So this is nothing but again your condensation polymerization. Okay. Hello.
Uh,
Hello.
Continuously, we are only studying three types of this thing. One you told this amide type of polymer. Another one is
Polyester.
polyester type, ester type, amide type, and
Yes. Then
type.
now this third one is like urethane.
All are condensation polymers.
Yeah, all are condensation polymers. Okay.
Okay.
These all are nothing but the examples of your condensation polymerization. Previously, we have seen the examples of your addition polymerization, which are mentioned over here. Okay,
Uh,
which are nothing but your polyethylene, polypropylene, vinyl chlorides, and PTFE.
okay.
Okay. So now, as of now, we have studied the condensation polymerization, or we can call it as a step growth polymerization. Okay. So now we will move forward for your addition polymerization.
So in that urethane, you are telling that you have marked and you told this is urethane, but
Linkage. Yeah.
linkage. But previous stage ester also same carbon is there,
No,
oxygen
no,
is
no, no, no.
there.
If you can see here, can you please focus on it? See what your ester is basically. It is nothing but your C double bond O OCH2 or something like that structure. Okay.
Amide and this one.
Okay. This is amide. Have you
Uh,
observed any
okay,
oxygen linkage over here in between your carbon and nitrogen?
no,
Okay, so
oxygen
it
is
is, that's why
carbon.
it is called as a that's why it is different than your urethane linkage. This is nothing but your amide linkage.
Okay,
Okay,
okay.
you can rightly mention on your means you can write down it like that way. C
Uh-huh.
double bond O NH, correct?
Okay.
And this is your
C double
C
bond.
double bond O NH, and other side OCH2 is there. So this is nothing but your urethane linkage.
Okay. Yeah. Additionally, OCH2 has
Yeah,
to.
yeah, correct.
Okay.
Okay. Yeah, there are many types of condensation polymerization. We are taking few of the examples.
Amide is a little stronger density part, which will have high density.
Yes,
After a product. Here it is density wise, it is very less. But
yes, it,
by elements, it is having more component.
yeah, it is again, it is again the part of your structural formation, or whatever monomers you have used. Okay, it
Okay.
depends on the structural form of your polymer.
Uh,
As I just now mentioned about that, we will see the structural effects, or the, you can say, structure property relationship, how your properties will get changed after your structure to structure, correct? So
Sir,
density is nothing but your property of your polymer. Okay.
uh,
So how density will get by differing your polymeric structure, that we will see. Okay.
sir, everywhere the CH2 is coming now. Is there any
Yeah,
name?
yeah, that part is constant, but it is varying in numbers,
No, what is
structure wise.
any name
Correct?
for CH2?
What?
Any chemical name for CH2?
You can see it as a methyl group.
Methyl group, huh?
Yes.
Okay, okay.
Okay. So next is nothing but your addition polymerization. Okay. So before starting this, can we take a break of 2 to 5 minutes? So we will restart it again after 5 minutes.
Okay, sir.
Okay. Hello, hello.
Hello, sir.
Yeah, am I audible to all of you?
You are
Hello.
audible to me at least.
Okay.
Yeah,
So
audible to me also.
yeah. That's great. Okay, so slides are visible to all of you again. Hello, the slide is visible.
Yes, sir.
Okay. So till now we have learned about the condensation polymerization, or we can call it as a step growth polymerization. Okay. So now we will start with our next like addition polymerization. Okay. So what is there exactly in your addition polymerization? Okay. So I just shift, pardon me for a minute. Okay. So what is there in your addition polymerization again? As we have know, addition polymerization is nothing but your continuously addition of your monomers to your polymeric chain, which will give you a chain with high molecular weight or number of repeating units, correct? So that is nothing but your addition polymerization. Okay. So in addition polymerization, majorly the mechanism or the synthesis process consists of 3 to 4 steps. Okay. In very first step, the very step of addition polymerization is nothing but initiation. Okay. The name itself suggests us the step. Okay. Initiation is nothing but your starting of your polymerization process. Correct. So what will we will see that thing in detail. Okay. So firstly, we will see the steps, which all steps are involved in addition polymerization. Second is nothing but the propagation. Propagation means after starting your polymerization, your chain will get propagate, or we can say more monomers will get add into your polymeric chain. Okay. That is nothing but the step we can call it as a propagation. Okay. And the last one we can call it as a termination. At the end, after forming the long polymeric chain, your chain should get terminated. Okay. Otherwise, it will form again more molecular weight chain. Okay. So to control the polymerization, we have to stop it. So to stop, we are having here one step which is called it as a termination. Okay. Or we can also call it as a chain transfer. These two things are nothing but say same. Okay. So again, there are, if you see, there are three types of polymerization techniques again in this addition polymerization. One is you can mention it in your whatever notes are there. There are three types of polymerization in addition polymerization again. One is free radical polymerization. Second is like anionic polymerization, and third is like cationic polymerization. Okay, these three are again means differentiate on the basis of your catalyst, or we can say it as a initiator, which we use for synthesizing polymer. Okay, so first of all, we will see free radical polymerization. Okay, so with example, I have mentioned here how your free radical polymerization works. Okay. So free radical polymerization is nothing but as of you all know about like addition polymerization will take place with monomers which is having double bond. Okay. Can you observe here double bond on your monomer? Hello. You are having this monomer here. Okay. Which is having general structure. Okay. If we consider this X as a H, it will be like ethylene monomer here. Okay. Hello. Hello. Hello.
Yeah, yes, sir.
Yeah. Am I audible?
Yeah, yes, sir, audible.
Yeah. So if you consider here ethylene monomer over here with unsaturation present, unsaturation means nothing but your double bond. Okay. So your double bond will get react in presence of your initiator to form polymer. Okay. So how it will form the polymer in presence of your initiator? As we seen here, three major steps are there: initiation, propagation, and termination. Okay. That three we will apply here only. Okay. So majorly for free radical polymerization, the type of initiators are used is like benzoyl peroxide or hydrogen peroxide. Okay, majorly peroxides are being used as a initiator in case of free radical polymerization. Okay, so in this case, this benzoyl peroxide or whatever peroxide is there, that peroxide will divided into two parts with free radicals. Okay, suppose if you can see here in this slide, this benzoyl peroxide is there. Have you seen this structure, benzoyl peroxide?
Mm-hmm.
Okay, if in presence of some heat, or you can say some external stimuli like heat, your benzyl peroxide will get divided into two parts. If you can see here, okay, in this step. So this is nothing but your radicals. Radicals form from your benzyl peroxide. Okay, can you observe here one dot is there?
Yes, sir.
Yeah, that structure we can call it as a radical. Okay, which helps to polymerize our monomers. Okay, so this structure you can remember, okay, for this step. So that
Previously,
free
the dot
radical,
was not there. Here only dot is there.
what?
In previous equations, you have not shown any dot.
Yeah, here na,
Yeah, the dot.
in
Here,
this slide you are talking about.
in this also it is the CH2 above
Yeah, yeah,
CH2.
yeah, that I am explaining now na. So if you consider this initiator, benzoyl peroxide is nothing but your initiator for free radical polymerization. Okay, so this benzoyl peroxide will get break into these two parts, or we can say two radicals. Okay, so these two radicals you can consider here as a initiator, at the place of initiator. Okay, so that radical will attack on your this unsaturation. Okay, and one of the weaker bond which we called it as a pi bond out of it, in double bond one is pi bond, one is sigma bond, correct?
Yes, sir.
Yeah, so weaker one is your pi bond. So after getting this pi bond break by your initiator, or you can say free radical, this pi bond or this pi bond will form covalent bonding with your initiator like this, and the other, like pi bond is nothing but your pair of electron you can consider, correct, or pair of radicals. Okay, so after breaking this pi bond, one radical will shift here to form your sigma bond with your initiator, and one radical will transfer to your end of your chain you can consider, or second carbon of your monomer. Okay,
Okay.
okay, so again the so in this step we can call this step as a initiation. Okay, here initiation of your polymerization get started, correct? So this radical, the monomer in form of radical, see here you can observe here radical presence is there, correct, on this carbon. Okay, so this radical again react with your second monomer. Okay, so again what you can observe here, again this pi bond of your second monomer will get break and attached to this your initiated structure to form a chain. Can you observe here a chain?
Yeah, yes. But there
Yeah,
is no carbon addition. Only all are H is there. One is X is there. But
yes, because see,
output we
if
are getting CH. No, carbon has to get added. From where carbon is coming?
here only, because this is nothing but your structure like C double bond C.
Okay, okay.
Okay, this is your C double bond C unsaturation structure is there of your monomer. Instead of
Oh,
it, you can consider here like if you have seen here this structure CH2 CH2. Have you observed here?
yeah, yes, yes, yes.
Okay, you can remember this. Okay, so here that monomer will get added into this step. So this step we can call it as a propagation. Propagation is nothing but your formation of your polymeric chain, correct?
Okay.
So your chain will get propagated with addition of several number of monomers. Okay, one by
Okay.
one. Okay, so this you can consider as your repeating unit, correct? This you are getting reacted n times. Okay, suppose this n we can consider as a 100. Okay, so we can react this monomer 100 times to it to get the polymeric chain.
Okay.
Okay, this is nothing but your initiation and propagation. Correct?
Okay, sir.
So if you see here, same thing is here. You can observe. Okay, your polymeric chain is getting added. Okay, so the last step which we observe here, which is like termination or chain transfer. So after propagation, we have to stop the polymerization of your polymer by, we can call it as a chain transfer reaction. Okay, what is chain transfer? It is nothing but if you are having two polymeric chains growing simultaneously. Okay, so if you are growing this polymeric chain and again second polymeric chain, correct? Hello.
Yeah, yes.
Yeah, this can you observe my cursor over the screen?
Yes, sir.
Okay, suppose this one polymeric chain is with us. Okay, and similarly second polymeric chain is there, the same like this. Okay, so both are having this radical structure.
Okay.
Correct? So both radicals will get reacted or get together and will form one bonding over each other. Correct? So that is
Yes.
nothing but your chain transfer, or we can say termination of your polymerization reaction. Correct?
Then after that, reaction will not happen.
Yeah, then after that no
Propagation,
radicals are present over your chain, so reaction will get stopped.
so propagation stops by then.
Yeah, that propagation step will afterwards get stopped by your chain transfer. Okay, so after that your chain will not get propagate, so your polymerization will get terminated. Okay,
Okay.
yeah. So have you understand these three steps:
Yeah.
initiation, propagation, and termination? Okay, in your addition polymerization.
Yes, sir.
Okay, yeah, this is nothing but in detail, like many of the initiators are there, as I have mentioned, benzoyl peroxide is there, then again AIBN, which have full form 2 azobis isobutylene butylene nitrile. Okay, this AIBN is nothing but again free radical initiator. Okay, again as we have divided this benzoyl peroxide in two radicals, similarly AIBN also get divided into your two radicals. You can observe here. Are there?
Yeah, carbon is radical.
Yeah. Okay. These radicals will get react or these radicals will initiate your polymerization. Okay. Yeah, here you can observe how your like benzoyl peroxide. See, here one benzoyl peroxide radical is there. Okay, at the bottom. Have you observed this?
Yes, sir.
Okay. So this you will get react with your ethylene molecule. The arrows can show you like this is a pi bond. Okay, so pi bond will get break, one of the electron or radical we can say move towards this, and plus this radical will get form a bond between them, which you can see here. Okay, and again the remaining one will get transfer here, which you can see here, this radical. Correct?
Mhm.
Yeah, so now it's clear for you, free radical polymerization.
Yes, sir.
Yeah, this is nothing but the coupling. As I already mentioned you, if two polymeric chains get together with the help of these radicals, they will connect. Okay, and the polymerization will get stopped. Okay,
But whether it is controlled by us or it is based on some
yeah.
automatic.
If you are adding, like suppose I am adding only 10 monomers. Okay, for each chain I am adding 10 monomers. Okay, one free two free radicals and 20 monomers. So one one chain will be of 10, 8, 9 or 10 whatever, and second will be of 8, 9, 10 whatever. Okay. So if they are not getting monomers to react, then what will they do? They will do same thing. Correct?
Okay.
It is depend on your concentration of monomers as well as your initiator.
Okay, at the end of the thing, each and everything will start reacting if they don't get
Yes, if your no, if your monomers will get over, then what it will do, what will happen there?
then it tries to get linked to its own pair.
Yeah, correct.
It will if whether there is any case that the pair is not got and it will have some other problem.
Yeah. So many examples are there for termination. First is like this, okay, like combination of your two polymeric chains with the help of radicals. Second is like disproportionation. In this, what will happen? Your hydrogen or whatever proton is there, it is shifted to your carbon, and then the linkage will get formed to terminate your polymerization. You can see here, okay. So many of the techniques are there to terminate your polymer, means polymerization. Okay.
It is done forcefully, by our
Yeah,
interference.
it can be done forcefully by adding some terminating agent or chain transfer agent. There are chemicals available, or you can say structures available which can introduce in your polymerization system to terminate the polymerization.
Okay.
Okay, which is called as a terminating agent, or we can call it as a chain transfer agent. Okay,
Okay.
yeah. Similarly, you can terminate the things. Okay. In this case, what will happen? Many side reactions are occurring. If suppose during the addition of your monomers, your radical is formed in between your polymeric chain. Okay, middle of or in between your polymeric chain. So on that side, your next monomer will get react. Okay. So from that point, other chain or other linkage, or we can say other branching will get start to form. Okay, so this kind of structure you will get in that case.
Is this called as networking?
We can call, but not exactly networking, we can call it as a branching.
Branching.
Okay.
If then again, if it is not networking, it is not a thermoset plastic. It is a thermoplastic.
No, it is not a thermoset plastic. Yeah, it is a thermoplastic.
Okay.
Okay. So the second, like first mechanism we seen here, like free radical polymerization. As before I have mentioned, there are again two type of polymerizations are there. First is means second is cationic and third is anionic. So first of all, we will see the cationic polymerization. Okay. So do you know what is cation, or what do you mean by cation?
Not sure, sir.
Cation having
Okay.
one
So
extra electron.
cation is nothing but the charge on your chemical species or charge on your chemical structure, which is represented by plus, or positive charge on your chemical structure, we can call it as a cation. Okay. So the polymerization start with the help of your cation, it called as a cationic polymerization. Okay. There are again some initiators which can be used for cationic polymerization, is like mineral acids, or we can say it as a Levy's acid. Okay. So these acids will form, or will form charge on it in presence, in form of, you can observe here, like see in third co-initiator system. Okay. So if this system is there, BF3 and H2O, see here you can observe here one positive charge and one negative charge is formed. Okay. So we can call it as a cation. Here H plus is there. Have you observed that?
Yeah, yes, sir.
Okay. So this is nothing but your cationic initiator. Okay.
Yes.
Similarly, in second, you can see here R plus is there. Okay. In that case, CH2 or you you can consider it as C2H5 methyl or ethyl group will be there. So that we can consider as a R. So R plus will form. Okay, that is nothing but your cation. Okay,
Mhm.
so in similar way, your initiation will start with the help of these cationic initiators. Here again, some of the examples I have mentioned here for cationic initiators. Okay. Okay.
What is this
So
purpose of this one? Cationic.
what?
What is this helping in
Yeah,
plastics?
that we are seeing now. See, here in initiation step, again the same monomer, or we can say monomer with unsaturation is there. Okay. So this positively charged ion, we can say to it, positively charged cation, okay, that will get attack on your pi bond. Same as, okay, same as your radical will get attack, correct? In your free radical polymerization.
Okay.
Okay. So again breaking of your pi bond and shifting the same charge on your next carbon. Okay. So again this whole system will get cationic form. Okay.
Okay.
So this cationic form, the monomer in form of cation will get react with will get react with your second monomer. Okay. Uh, okay. Someone is sending some messages. Just wait. I think okay. Now your the slides are visible to you.
Yes, sir.
Okay. So your second monomer will get react with your that complex which we formed before, this positively charged monomer. Okay. So that get propagated as we seen in your free radical mechanism, correct?
Yes.
So in similar way, what we observe here, okay, instead of your free radical, we are using cation. Okay. Hello.
Yes, sir. Yes.
Yeah. So what all kind of polymers can be formed using cationic polymerization? So here you can observe what all kind of polymers can be formed. So do you know about the styrene or polystyrene?
Yes, sir.
Yeah, polystyrene. So the polystyrene can be formed using the cationic polymerization using the initiator like TSCl4 and this way SnCl4. These are the initiators can be used for polymerization of your styrene. Then again isobutylene, or we can say it as a butadiene, or we can know, we are knowing about the butadiene rubber in that way. Okay, so that butadiene will form using your isobutylene monomer. Okay, so that will we can synthesize using this cationic polymerization. Okay. Hello.
Yes, sir.
Okay, so these are the some examples which we can synthesize using, or these are the some polymers which we can prepare using our cationic polymerization. Okay, so the third is nothing but your anionic polymerization. Okay, so as we have seen, like uh, free radical, using your radical you can synthesize your polymer, then cation. Then what is anion? Anion is nothing but the negatively charged ion. Okay, you can observe here the example. Okay, so that negatively charged ion will initiate your polymerization reaction on first monomer. Okay, as you can see here. Okay, and then you will get the first monomer with this anion on the carbon, correct?
Yes, sir.
Yes. So what is the difference between cationic and anionic polymerization is like we can synthesis the polymers which contain nitro, cyano, or carboxylic or vinyl or phenyl functionalities over it. Like suppose if phenyl means what? Phenyl is nothing but your uh, benzene ring on your, like suppose CH2 CH, this structure is there, and instead of R is some benzene ring is there. Okay, so that monomer we can call it as a styrene. Okay, so that styrene will get react using this anionic polymerization. Okay, hello.
Yes, sir.
Okay, so in similar way we are having that same steps like initiation, propagation, and termination in this also. Okay,
The purpose of this one is only termination, no?
uh,
Anionic and this
no, 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 no.
cationic.
These three methods are
No,
totally.
instead of that radical bonding, this goes and does the bonding means it is also used then.
No, no, these three of methods are totally different. Okay, in these three methods again three steps are there. Okay, as you are having initiation, propagation, and termination in free radical, the same steps are in cationic polymerization, and that same three steps are in your anionic polymerization. Okay, in anionic polymerization also you are starting your reaction with anion. Okay, anionic initiator. Okay, the anionic initiator will start your addition reaction. Okay, so that's why it is called as a anionic polymerization. Okay,
So,
in
this is
cationic,
happening in addition polymerization method. Huh?
yeah, these three are addition polymerization methods.
First three is that is like condensation type. Huh?
Yeah, that what we see in the examples. Okay, at the start, that are your condensation polymerization. These are nothing but your addition polymerization.
Addition polymerization.
Yeah. Okay, so these are some common initiators used for anionic polymerization, which are given here the examples of it. Okay. These are the mechanism and the reactivity of anionic polymerization, which we can be seen in your structure property that lecture. What are the reactivities means what it will affect to your properties. Okay. So these are these some of the examples you can see in here. This kind of polymers we can synthesis using your anionic polymerization. One is your polystyrene, polybutadiene, and then PMMA, or we can say it as a polymethyl methacrylate. PMMA, all of you know about, which we consider as a transparent plastic. Have you seen any PMMA transparent plastic?
No, we have
Okay.
seen PMMA that plastic trim clips
Yes.
having a lubrication.
Okay.
That is a PET. Sorry, PET. I think that is a PET.
That is a PET.
Yeah.
Okay. So PMMA can be synthesized using your anionic
Where we are
polymerization.
using PMMA?
PMMA generally for shield, we can say, if you are considering transparent sheets, or have you observed any transparent sheets for like uh, if you want to fill the gaps of like AC vents, or in that way, suppose AC room is there, and in case of some means if you can't put wall over there, so you can put the sheets. Okay, the transparent sheets are made up of out of your PVC, or you can, if it is hardened, then it is of your PMMA. Then your nameplates. Have you seen any nameplates on whenever some
The
conferences are there?
transparent, we can use a PC also. Then why PMMA?
Yeah. So both are having different properties. Correct. PC is having more brittle, or you can say compact structure than your PMMA. Correct. You can use both. Correct. But PMMA having its own structural characteristics.
But okay, if I talk about application point of view, what is the
If suppose some impact or some you can say like is there any flexibility over your PC structure? PC is having some flexibility, because if you consider the impact, which one will give the better impact out of that?
That's what don't know. I'm asking you.
Yes.
Which one? I don't know. Sorry.
Yeah, it is based on your application purpose. Okay.
That's what. Which one having more impact strength?
Yeah, comparatively, I'm asking about. It is not like PMMA having better, but comparatively, PMMA having better than your PC.
Uh, okay.
Comparatively, I'm asking. Okay? Not like
Okay.
okay. So commercially, these are some important examples for polymers which we can have with us, like polymer or copolymer or its major applications. If you are synthesizing polymer using cationic polymerization, you are having examples like polyisobutylene or polybutene. Okay, what is it is nothing but your butyl rubber, or we can call it as a synthetic rubber, correct? So that can be synthesized using your cationic polymerization. Again, what other examples are like hydrocarbons and polyterpene resins. Okay, or we can call it as a fumarone or indene resins. Okay, which we generally use for inks, varnishes, paints, or adhesive purposes. Okay, then what all kind of polymers we can synthesize using anionic polymerization is like, again, butadiene we can synthesize using anionic, or isoprene, polyisoprene. What is polyisoprene? It is nothing but your unit of your natural rubber. Okay. Again, styrene butadiene rubber, SBR. Okay, which is a kind of rubber again that we can synthesize using anionic polymerization. Okay. Then these are the, now we have seen about the chain reaction, or we can say addition polymerization, and step reaction, or we can call it as a condensation polymerization, correct? Hello.
Yeah. Correct.
Yeah, so these are the major differences between then both of the types. Okay,
Sir,
then
but
now,
why there are different types of polymerization? This thing, why can't it be one or two? Because here anionic, cationic, and all, there should be
yes,
some
yes,
base this
yes.
thing requirement, no?
Suppose
Because
if you are, suppose if you are synthesizing a special kind of polymeric material, or you can say a specific polymeric material. Okay, so in that case, if your monomer is compatible to polymerize with some, suppose some of the monomer, suppose some X monomer you have taken. Okay, suppose we can't synthesize it using anionic polymerization, or we can't synthesize, or we can't initiate its polymerization using anionic polymerization. Okay, so what will be the next you can try? It is like a free radical, or we can try it uses a anionic. Okay,
okay, then if then what is the purpose of this plus anodes and
yeah,
negative?
that's, see, now we have taken examples of like simple unsaturation, like simple C double bond C structures. Okay,
Okay,
so in that case also, depending on the reactivity of that unsaturation. Okay, if I have put some functionality over there on one carbon, we are having two carbons on one monomer, C double bond C, correct? So out of which
yes,
on one carbon, if you keep some functionality over it. Okay, suppose I have kept over there some acrylate functionality. Okay, so its
okay,
electronegativity or whatever the reaction conditions, or that may get changed. Okay, so over there your single or the single method cannot be worked. Okay, depending on your reactivity.
okay,
Okay, that's why many of the examples having common, you can observe here, many of the examples are common, like polybutadiene you can synthesize using anionic as well as cationic, but some of the examples are different. You can't synthesize the same using cationic polymerization.
okay.
Okay, so depending on your monomer system, your polymerization technique will get changed. This
What
is
is the
the,
base for that possibility and not
yeah,
possible? That what is the base?
again, yeah, again I will tell, like, be like, it depend on your functionality of your monomer. If it is having more electronegative tendency, then you have to means on that basis your initiator will get changed.
Now, maybe is that neutralizing something like that? Otherwise, the chain reaction will be
Yeah, it is
continuing.
having some effect on your unsaturation. Okay,
Okay.
due to the presence of your functionality, your unsaturation will get your that reactivity will get affect.
Okay.
Okay,
Okay.
so it is again nothing but the in-depth part of your chemistry. Okay,
Okay.
chemistry of your monomer or reactivity of your monomer, because
Okay.
every monomer will not get react similar way. Correct?
Yeah. Yes. Yes.
Yeah, that's why the techniques are there. Okay, so here are the basic differences between your step growth, or we can say it is the condensation polymerization and addition polymerization. Okay, so you can see here the growth occurs throughout the matrix. Okay, in step growth polymerization, you can say at from both end you can polymerize it. Correct? But in chain reaction, only a single, or you can say a successive addition of monomers will get reacted. Like at only one direction you can react your monomers to form a chain. Okay, you understand this? Hello?
Group reaction.
Yeah, so again we will move for explanation of this. At least for chain or addition reaction, do you know that
That
the
ring opening, something that was we studied. That and chain has have any relation?
it is if you neglect the chain opening part, okay, then it is similar as your chain growth reaction.
Okay. So it's
Okay,
a reverse
the
of
only
chain.
thing is you will get some of the byproduct over there in some cases, or will not get.
Okay.
Okay, depending on type of monomer.
Okay.
Okay, so the first difference we can explain from this. In this is nothing but your addition polymerization. Okay, you can observe here your monomers will get added from this side only. Correct?
Yes.
Okay,
Radicals are there.
yeah, and if you observe like your condensation product, okay, so your monomer first monomer will get added from this side, and second will get added from this side as well. Correct?
Okay. Yes.
Yeah, so that is the first difference in your step growth and chain growth polymerization. Correct?
Okay.
The growth occurs throughout the matrix, and the growth occurs by successive addition of your monomer.
Meaning is chain will both side it will react. Step is only one side.
No, chain will from one side, and step means nothing but your condensation polymerization.
Okay.
Chain reaction means your addition polymerization.
Okay, sir.
Correct? So
Okay.
second is like reaction between monomers, oligomers, and polymers. Whatever it is, like if you synthesize it some oligomer, then it will get react with your second oligomer to form a polymer. Here only monomer units will the number which we are using for growing of your polymeric chain. Okay. Then degree of polymerization, what we have seen on one of the slide, degree of polymerization is low or more low to moderate in your condensation polymerization, and here the degree of polymerization is higher. Okay, because high molecular weight products will get formed using your chain group polymerization. Okay, then more in your condensation polymerization, monomer consume rapidly while molecular weight increases slowly. As we have seen in first point itself, the monomers consume rapidly because it is growing from both the ends. Correct? Correct?
Yes, sir.
Yes. And in this case, monomer consume relatively slowly because the growth is from one at one direction only. Okay. Again, the no initiator needed for your condensation polymerization. Have you used any initiator?
No.
No. Okay. And in addition polymerization, initiation and propagation mechanism are different. Means initiator is needed. Okay.
Okay.
Again, the difference is like no termination step and groups still
Now this
reacting.
cation anion is also initiators, huh?
What?
Cation anion that
Yeah.
actually
That is in your addition polymerization only, or you can say chain
no,
polymerization.
that is also we call it as initiators, huh?
Yes. That are initiators.
Those are also initiators. Cation
Yes.
anion both are initiators.
Yes.
Okay.
Okay. Here, no termination step is there. Have you observed any termination step in your condensation polymerization? Because
No.
at the end, as your polymer chain will get formed, the end groups are still present in your polymer in condensation polymerization. Want to see that? See, we can move backward for this. If you can consider here, this is the polyurethane. Again, at the end, this NCO is remain there. Okay. Suppose this is your total polymerized product. Okay. Suppose this is the last functional group like NCO. Then if you add some polyol to it, it will again react. Okay.
So this is one of the reason for attracting that moisture also, no?
Yeah, you can say, but this is the reason why we want to add cross linker or hardener to your condensation product.
Okay.
Okay. Due to this unreacted functionality, we are adding cross linker here to get react with this functionality to cross link your polymer. Okay. Yeah, this is the main reason why we are using cross linker for your condensation polymerization. Okay. So in condensation polymerization, your polymer consists of end functionality. Okay. Active end functionality, you can say. Again, in this like in chain polymerization, after termination you will get the dead polymer molecule. What do you mean by dead polymer molecule? Because you can't react more monomers to it after termination. Okay. Hello.
Yes, sir.
Okay. So these all are the differences over your step polymerization and, or you can say condensation polymerization and addition polymerization. Okay.
But again, this is not a thermoset, no? Because if we cannot add,
Yeah. So whatever polymers you will get it from condensation polymerization, that we
uh,
can call it as a thermosets.
condensation thermoplastic, no?
No. Addition from, yeah, some of the polymers you will get thermoplastics, but majorly polymers you are get from condensation polymerizations are your thermosets, and majorly polymers which you get from addition polymerization are your thermoplastics. Okay.
Okay. Okay.
Like polyethylene, polypropylene, polystyrene, whatever the polymers are there, which we get from addition polymerization, which we called as a thermoplastics. And whatever polymers we have observed here, like polyurethane, polyurethane is both thermoplastic as well as thermoset, depending on application. Okay, depending on application as well as formulation of your monomers. Okay,
Okay, sir.
yeah,
But amide is coming in step only, no?
yeah. Amide. See, similarly, amide can be thermoset, can be thermoplastic.
Okay.
Okay, because polyamide coatings are also there, polyamide plastics are also there. If you are considering polyamide coatings, then you will get it in form of thermoset, and if you are considering polyamide plastics, then it is a thermoplastics. Okay.
Okay. Okay, sir.
It again depends on its formulation of its monomers and reaction mechanism, or you can say polymerization techniques.
Okay.
Okay. So till now, everything is clear for this polymerization techniques.
You mentioned that addition will be a thermoplastic, right?
Yes.
And thermosetting will be a condensation.
Majorly polymers synthesizing using addition polymerizations are your thermoplastics.
Okay.
And using condensation, you can polymerize thermoset as well as thermoplastic.
Okay. Okay.
Okay.
Yeah.
Yeah. Is there any doubt in this again?
No, just I was thinking how it will be useful because mainly chemistry. We study at 12th level, all this level kind of.
Yeah, because see, this is whatever I explained here is not in depth of chemistry of synthesizing your polymer. If I supposed to teach you the chemistry of polymerization, you are not able to understand in detail. Okay, because it polymer means polymerization is nothing but more to polymer chemistry part. So that's why I just explain you in brief, not means not in depth, but at least to understand the polymerization, means how your polymer will get formed from your monomer. Okay, that is the main motto of this lecture. Okay,
Yeah.
Yeah, yes, sir.
so now till now have you understand how your polymer will get formed? See, these are only the polymerization techniques or polymerization methods or types of polymerization here we have mentioned. Okay, so in I think upcoming your lectures or a series of lectures, many of the polymers are you are going to learn individual polymers. Like if you are you we are taken here example of polyester, correct? So on polyester, one separate lecture is there. Okay, so many of the common polymers we are having separate lecture on it, correct? Maybe you are having that schedule with you.
Yeah.
Okay, so in that we will learn about the individual polymers. Okay, hello.
Yeah.
Yes.
Yeah, it is there. I seen that. Yeah, it's
Yeah,
plastic material, polyolefin, vinyl polymer.
yes. In that you will learn about in much details about the polymerization
PP is not there.
synthesis.
PP is not there. Any reason?
Yeah, it is. See, whatever the polyolefins. Okay, polyolefins nothing but your polyethylene, polypropylene,
Okay.
polyvinyl chloride, and all. Okay, the synthesis method or synthesis techniques is nothing but your addition polymerization. The similar way that all are getting synthesized. Okay.
Okay, got it.
Yeah. So majorly what the difference is in polymer or polymeric material, whatever the needed examples are there, that only I think they have mentioned in your coming lectures.
Yeah.
Okay.
But just what is the end usage of this polymerization? In which industry it will help for particular user kind of
Yeah,
just
it is usable in industries like whatever raw material synthesis of polymers. Means suppose if you are taking some polyethylene granules, okay, so how that granules will get formed by which monomer means by reacting which monomers it will get formed. So
Sir,
in that synthesis industry means polymer synthesis industry
is it useful for the R&D people or manufacturing people?
for for manufacturing means which manufacturing I am talking about, the
For the
manufacturing of
granules.
your polymeric material,
Ah,
not application, means not processing of your polymer.
ah,
Okay, this is just a synthesis of your polymer.
okay.
Okay, and some of the R&D like if suppose some people are working on modification of polymers in that way, or some they want to defer some applications. So in that case, you can refer these things.
how in that in case of application.
Not in case of applications I am talking about. If you are doing some modifications to your polymeric material, okay. Suppose if you want to increase some grafting of your polyethylene, okay. Many of the grades are available in market of polyethylene, correct?
Yeah.
Yeah, majorly like normal polyethylenes are there, grafted polyethylenes are there, okay. So that how that grades are differ from each other due to their structure, due to their polymeric structure, and that structure will you will get form using these polymerization techniques.
Okay.
Okay.
Mm. Basically, different grades. We are adding some
Yeah,
Filler or
now
additives.
if you are polymerizing your ethylene molecule again and again, so you will get polyethylene, correct? If you want if you like want more cross-link structure, then you will introduce some of the other chemic or some of the other monomer which will
Additive or filler, right?
not additive. That part is different again. That is your processing part.
Okay.
Okay, I am talking about the reaction, polymeric reaction. If you are
You
instead
are
of
talking
your
about inbuilt granular, inbuilt granular, right?
no, in your granule, that is in your polymer. Okay,
Yeah.
suppose here your ethylene is there, correct? This
Yeah.
is nothing but your ethylene, okay, which is monomer of your polyethylene, correct?
Yeah.
Yeah, we are only repeating this unit only in your polymeric chain, correct?
Correct.
Suppose someone or if you some of the grade or if you want more cross-link structure of your ethylene, okay, with different grade, so you will add some other monomer which will provide you the cross-linking. Okay, suppose 10 monomers, 10 ethylene monomers and one cross-link, the monomer which will give cross-linking, if I add here, then the grade will get differ from this regular, correct?
Yeah.
Yeah, so in that case you will get more cross-link structure.
Yes.
Okay.
Yeah. Actually, it is looking like a little bit difficult for me, especially because
Yeah, because it is a polymer
all this
synthesis part.
chemistry. I think if we can maybe some basic, maybe we can go through that. That will helpful.
Yes,
But
yes, yes.
but anyhow,
That
this are we going to use this type of things further classes? All this, then we have to
yeah,
basic.
in I think whatever polymer materials are there now, individual polymers are there in your upcoming lectures. In that you will get idea of how your monomers will get react with.
Then maybe if we can some basic class like chemistry structure like that, maybe atom or
I think basic chemistry class will not be there, I think. Okay.
okay. Okay, anyhow, that if some
Okay.
because basic I
So
forget
this
what
is
I
all
did.
about your polymer means basic polymer chemistry means like you can say to understanding of polymerization and all. Okay.
Yep.
So we will take these all are the polymer reactions. Okay, or we can say the reactions from which you will get the polymer. Okay, so again there are four different techniques by which you can synthesize the polymer. That are not the reactions, that are techniques. Okay,
Okay.
hello. So there are four different techniques to synthesize your polymer or to form a polymeric material. Okay, that techniques we will see in your next lecture. That is of tomorrow's lecture. Okay.
Okay. Can we get that PPT which you are presenting, please?
Yeah, we will definitely share the PPTs with
By when?
you. I think as per the means as per every year, we just have to confirm it with your coordinator. Okay.
Because last two classes we are still waiting for the PDF.
Yeah. We will ask your coordinator. Okay. We'll share with them. Okay.
Mm.
Or we'll share with him.
And also
He
the
will.
recording classes we are getting very late. And if we
I
get
think
on daily or
he only can share you the recorded classes. You can coordinate with your coordinator of your course.
okay, we'll send a mail.
Yeah.
Maybe other team
And
member also can send a
yeah,
mail.
you can coordinate with him. And again we will send the ppts to him only, so he will share
Okay.
with you. Okay.
Yeah.
Yeah, so till now for today we will stop here. Okay, and again we will start our next lecture tomorrow. Okay, on polymerization techniques. Okay.
Okay.
Okay, thank you.
Thank you.
Sir, thank you.